In this video, I will show you how to prove that a certain quadrilateral is a parallelogram using the coordinates. And then we will also prove a special property of the parallelogram. We will prove that the diagonals bisect each other. Given that ABCD is a parallelogram, first let's go through and mark all of the things that apply to a parallelogram. It has two pairs of parallel sides. Am I going to mark that off? Yeah, two pairs of parallel sides. That's the very definition of a parallelogram. So we'll definitely check that off. Exactly one pair of parallel sides? Well, no. We already said it has two pairs. All four sides congruent. Is that a parallelogram thing? No, that would be a rhombus. One pair of congruent. Look, we already said it has two pairs. Okay. Both pairs of opposite sides are congruent. Am I going to check that off? Yeah, that's true. Okay. Parallelograms, the opposite sides are congruent, both pairs. Two pairs of consecutive sides congruent. Only if it was, and it says but not all four. So this would be a kite, would be the only thing that fits this description. Not a parallelogram. There are four right angles. Is that a thing for parallelograms? No, that's just rectangles. Okay, diagonals perpendicular? No, that's like rhombuses and kites and squares. Diagonals congruent? No, that's rectangles and isosceles trapezoids and squares. Diagonals bisect each other?
Yes.
That's the one. That's the one for parallelograms. Okay, so these are the things that we've got. Let's plot these points to help us out. Okay, so -4, 3 would be right here. All right, so there's point A. And 2, 4, so that's B. 1, 1, that is C. And -5, 0, and that will be point D. All right. Let's connect these up real quick. Okay. Use calculations and words to show this quadrilateral meets the definition of a parallelogram. So remember, the definition is two pairs of parallel sides. So I need an introduction, a main body, and a conclusion. So your introduction should say something like, I will show this is a parallelogram by showing opposite sides have the same slope. All right? And that last phrase is the key, same slope. When I'm grading your introduction, if it doesn't say same slope in there somewhere, then I'm going to mark that portion of the problem wrong. Okay, now it's time for the main body where I actually do what I said I was going to do. So slopes, we need to find all of the slopes. So let's do it. Let's do slope AB. Okay, so slope AB, rise over run. There's the rise, there's the run. Is this positive or negative, you guys? That's positive. It's positive 1 over 6. Thanks for your help. Okay. So positive 1 over 6. Next, let's do slope BC. Okay, slope BC. All right, so here's the run and here's the rise of BC. Is this positive or negative? This is positive also. So the rise is 3 and the run is 1. So 3 over 1 is just 3. So this slope is a positive 3. All right, next let's do slope DC, which would be like this. Is that 6 again?
1 over 6.
Okay, so 1 over 6. 1 is the rise, 6 is the run. So 1 over 6. Positive. It's uphill again. They are all positive. Look at that. Okay, so that was slope DC. Slope DC is 1/6. And that leaves slope DA, which is 3 over 1. Which is 3. All right, as you glance at these slopes, what do you notice?
They're two pairs of the same.
Yes, and because we went in order, you can see that, see how it goes every other one? You know, like these two are congruent, and then the 1/6 and the 1/6, those slopes are the same. I shouldn't say congruent. Those slopes are the same. They're not consecutive. That's why they're skipping like this, okay? So this is showing that opposite sides have the same slope. Opposite sides are parallel. So now we can do the conclusion. All right. Since opposite sides have the same slope, then opposite sides are parallel. Therefore, this is a parallelogram. Next, we need to use calculations and words to demonstrate one property that must be true about the diagonals of a quadrilateral. And as soon as I see use calculations and words, I know I'm going to need an introduction, a main body, and a conclusion. Well, we only had one property of the diagonals of a parallelogram, and that is that the diagonals bisect each other. So this is what we're about to prove, this right here. The diagonals bisect each other. And the way you prove that diagonals bisect each other is by showing that they have the same midpoint. We need to show that they have the same midpoint. So that's what I'm going to say in my introduction. I will show that the diagonals have the same midpoint. Now it's time for the main body, where I will simply do what I said I was going to do. So what are the diagonals of this thing? So please understand that the diagonals of a parallelogram are like this. You know what? Maybe I'll do this using my line drawing tool. So here's one diagonal. AC is a diagonal. So maybe let's go ahead and do that first. So AC, so I'm going to be focusing on these endpoints right here. So the way that you find the midpoint of AC, all right, so I'm going to find the midpoint of segment AC. It is the average of the x's and the average of the y's. So the x's are the -4 and the 1. So I will do -4 plus 1 divided by 2. That's the average of the x's. And now the y's, that's 3 and 1. So that is 3 plus 1 divided by 2. So let's see, -4 plus 1, that is -3 over 2. And 3 plus 1 over 2 is 4 over 2. All right, so in the end, that will be -1.5, comma 2. All right, that is the midpoint of AC. Now, that's the midpoint of one diagonal. Now let's find the other diagonal. The other diagonal is DB. Those are the only two diagonals. So the midpoint of DB. So that means that I should be focusing on the endpoints DB when I do the midpoint. So here is B and here is D. Focus on those for the rest of the problem. Okay, so midpoint of segment DB. All right, so again, average of the x's and average of the y's. So the x's are 2 and -5. So I'm going to go 2 plus -5 over 2. That's the average of the x's. The y's are the 4 and the 0. So that's 4 plus 0 divided by 2. So that's going to give me -3 over 2 and 4 over 2. So in the end, I will have -1.5, comma 2. So this is the midpoint of DB, segment DB. Of course, you'll notice that they are the same. So it's time for the conclusion. So I will say, since they have the same midpoint, the diagonals bisect each other. So that is how you prove things using coordinates.